Now we have done with this relative lowering in vapor pressure. Now we are going to do elevation in boiling point, right? So just look at the board that what is elevation in boiling point. As the name suggests, that means boiling point just increases when you add non-volatile solute into a solvent. Just look at the board how, right? So see what happens. Suppose I have a, you can say a solvent. I'm just talking about a pure solvent, right? So that means if I'll heat the solvent, what I get to see? I get to see the bubbles coming out. I get to see a formation of bubbles, little bubbles. But as I continue heating, then what happens? Ultimately the vapor pressure will increase, and when the vapor pressure will become equal to the atmospheric pressure, the liquid will start boiling. That is called as the boiling point is achieved, right? So that means when we are heating anything, so that means vapors are forming, and when the vapors, you know that the vapor exert vapor pressure, and when that vapor pressure is just going to become equal to the atmospheric pressure, the liquid is going to boil. That is our boiling point, right? And you know that like at normal conditions we take atmospheric pressure as 1.01325 bar or as 1 atmosphere. So that means our vapor pressure should be equal to this much, and when it becomes equal to this much, then you can say the liquid will start boiling, or you can say the boiling point is being achieved. Now what happens when, suppose I take a solvent and I'm just going to make a solution in which I have a solvent and I'm going to add non-volatile solute. I'm going to add non-volatile solute. So what happens when I'm going to add non-volatile solute? So you know that on adding that, vapor pressure just decreases. Vapor pressure just decreases. So that means I have to supply it with more heat in order to make vapor pressure equal to atmospheric pressure, because the vapor pressure is almost low, right? So that means more heat is to be applied in order to form more vapor, so that it has more vapor pressure, and more heat is required to make vapor pressure equal to the atmospheric pressure. So we can say in like the solution that contain a non-volatile solute, for that the heating has to be more. That means the boiling point will show an elevation. That means the boiling point will just get increased than the normal one. So that is the boiling point for the solution is higher than the boiling point as compared to its solvent, pure solvent. So that means there exists an elevation in boiling point. There exists an elevation in boiling point. Let me explain you graphically. Suppose I have this graph. I am going to make vapor pressure with the temperature graph, and this is my 1 atmospheric pressure. And you know that when the vapor pressure becomes equal to this, boiling point gets achieved. So what do we get to see in solvent case? We get to see, let's start with here. So we get to see that this is a solvent graph. And when the temperature corresponds to this point, this thing, you can say boiling point is being achieved. But when we see for the solutions, so I told you that vapor pressure is comparatively less. So that means it will show a graph something like this, because they possess less vapor pressure. So that means their vapor pressure will become equal to atmospheric pressure at this temperature. So let us say this as Tb. So as you can see that Tb is somehow greater than T0B. So this indicates the elevation in the boiling point. And how much elevation? We can calculate that by the expression. So elevation in boiling point is nothing but equal to the higher boiling point minus the lower ones. That means the boiling point of the solution minus the boiling point of the pure solvent. So as we conclude that this elevation in boiling point is just equal to the molar concentration, molal, I must specify molal concentration of the solute. So that means that elevation in boiling point is just directly proportional to the molar concentration, which proves that it is a colligative property, because we know that colligative properties are those which depend upon the number of solute particles, not on the identity. So this is how I just want to prove that it is a colligative property. And we need to have an expression also. So I will remove this proportionality sign. After removing, I get the constant Kb. Kb is molal elevation constant, or you can say ebullioscopic constant. And if we take concentration of solution as 1 molal, then delta Tb is definitely equal to Kb. But when the concentration of solution is 1 molar. In that case, it is equal to Kb. And you know that hence it is proved that it depends upon the molar concentration of the solute, and that means it is a colligative property. We may have this thing, we may found a numerical on the basis of this elevation boiling point where we are asked to find the molar mass. So we can do it, we can relate it with the molar mass as also. So look at the board carefully. How? Delta Tb is equal to Kb into molality. This is what I told you. So I am just going to write the expression for the molality. What is molality? It is number of moles of solute divided by weight of solvent in grams. So I am going to multiply it 1000 because molality is 1 kg. Here I am using grams, so that is why I have multiplied the numerator with the 1000. So this is what I have. Now as I know that I can have the number of moles also, that is Wb upon Mb. This weight of solvent is already here and into 1000 is already here. So that means by using this expression I can calculate the molar mass of the solute if I wish to. If somebody asks me in the numerical to calculate with the given elevation quantities of elevation boiling point, I can do in this way. So this is what I just want to explain you, that whenever a non-volatile solute is present in a solvent, it is just going to decrease the vapor pressure, and we know that the boiling occurs when the vapor pressure just become equal to the atmospheric pressure, right? So that means we need to supply it with more heat. More heat means it will take more time for the vapor pressure to become equal to the atmospheric pressure. So that means somehow our boiling point is going to get elevated. That is what is the elevation in the boiling point.